Hey, evening, sir.
Hey, Paz, how you doing?
Okay. We haven't been having any work experience class from since last week. I'm not sure if Mr. Pierce is aware that his name is on the timetable.
Oh, it's Mr. Pitt is on leave, you know. So okay, so no work experience class at all?
No, no problem.
All right, let me just reach out to him right now.
And they have work experience on Saturday, but there was no link sent out last week.
I recognize no link was sent out for Saturday.
Mhm.
This is year four, uh, year four, NV, Environmental Studies. Since when?
Yeah,
Pause.
man, from since last week. So that's what hold on. We'll have classes on Tuesday and the Saturday. Yeah. So that's from since last week, Tuesday. Mhm.
And who is the lecturer for the thing?
Mr. Pierce, for Saturday, I'm not seeing a lecture.
All right. Message to him sent. He will soon respond to me. Thanks for the update. Are the other lecturers going to their classes?
Yes, sir.
Okay. Paz,
Yes, sir.
uh, you went to work today?
Yeah, I did.
Um, work is, sorry, home is east?
home is east.
Mhm.
No, to the north.
You had a lot of
To
traffic
the
going
north.
on?
Um, no, because I ended up leaving early today. So
Oh, okay.
left before the traffic. Yeah.
Well, I was on the road and ready about 5:30. I said that it would be enough time to get home um for 7 o'clock. And I texted because the traffic was awful. So I will be I'll be
Having
wrapping up.
classes from home.
Yeah, I'm at school now. Yeah, I'm in office now.
Mhm.
So I'm going to be wrapping up at about 8:30-ish. I don't want to be here so late. And
Mhm.
needs be, I will just continue on the phone. So I won't be sharing my screen, but I can continue on the phone, maybe for another 15 minutes thereabout. So see if you can rope in your classmates and so we can get an early start, please.
All right. Yes. One
Mhm.
more thing as well. In relation to the timetable, are we gonna get a amended timetable or not?
In terms of what?
All right.
The
So,
social outreach? Tell me the issue.
all right. So practically year three and year four timetable, they are not in sync. Um, we don't have any. The timetable for year four is not showing Thursday where we would have classes. So there are some missing days on the timetable. So we should have
Oh, so
research methodology on.
my class is not showing.
Yeah, it is showing, but for like the Thursday class, we were supposed to have research methodology, but it's not there. So we had to let Miss Budapati know that we were not seeing it on the timetable.
Let me see if I can.
So I was hoping to see, the timetable before I selected the courses because I don't want it to be a case where I have to drop anything or add.
Let's see if I can get onto the system.
Or I can share a screen because I have it open.
No, it's not even that thing. I just need to go on and see what amendments I can do. You have the times for good parties class?
Um, yeah, I wrote it down. Don't have it. Thursday from 8 to 9 p.m. and Friday from 7 to 9 p.m. That's what she said.
All right, hold on. I'm just trying to log on here. ENV. So I'm finding you now. Environmental year 4. All right, so year 4, what I'm seeing there, I'm seeing work experience on a Saturday from 3:30 to 4:30.
That's from 3:15 to 4:15
3:15 to
on
4:15.
Saturday.
All right. Okay, yes, you're correct. 3:15 to 4:15. And I'm seeing urbanization and environment with Waldo 5 to 7.
Yeah. Mhm.
Environmental engineering Dunbar 7 to 9.
Yeah.
Uh, but I'm not seeing chemistry on it.
That is all right. So that is the issue. But when you go on year 3 now, you would see that for Tuesday. So it
Yes.
really
So when I go
was
to
confusing
year 3, yeah, when I go to year 3, you're seeing chemistry and you're seeing chemistry for year 3
on Tuesday
uh,
and the work
and Thursday.
experience. Yeah.
All right. So let me just um, um,
Good evening.
Hey, good evening to you. Um, okay, so I want to have access to view there.
Good evening, sir.
Good evening. Is um, okay, Senate account. We cannot drop BSc Eve environmental year 4 here. Hmm. Um, BSc year 4. No. Um, Year three. Resources. Consolidate. Year four. Sure. That is year three. So if I all right. Okay. But if hold on now. Today is 79. All right, pause. I have successfully added. I successfully added. Hold on. Hold on. Thursday is what time? 5 to 7, 5 to 9, right?
With 5 to 7 for chemistry.
5 to 7, sorry, 5 to 7, 5 to 7. All right. Let me go back to year three, Thursday. I'm gonna copy the year four to that time. All right. Where do you check a timetable on you can check your timetable now?
Yeah, I can check it now.
All right, check it to see if it's reflected, please, because I just did it. Year four. Year four. Year three. All right.
I'm not seeing changes.
I'm not seeing any changes yet.
Mhm.
All right.
I added the research methodology as well.
Oh no. But I did make the thing. But the research, no. When you said the research is?
Thursday 8 to 9 p.m. and Friday 7 to 9 p.m.
Okay, so I'm trying to find out where is that research. Um, look, which group you have the research with?
Hospitality and tourism. Dr. Godapati.
Hospitality. BSM, them, THEM. Um, 3 or 4, year 3 or year 4?
The group is year three.
what it says. It's what it says. Each EHETM What is it? Tell me what code is it?
One second. RMTD 3401.
No, not the first code, you know. When you look on the timetable, it will tell you which group you belong to. EBSC NVI4. What is it?
Oh,
EHEP3TEM.
All right, so EHET3TEM.
Yeah.
Oh, Rockstone, there are two of them. No, there's one of them. All right, found it. And research methodology, seeing it on a Thursday, 8 to 9.
Yep. And on a Friday,
yes,
7 to
9.
9.
7 to 9.
Yeah.
All right, hold on. I don't know. I'm gonna try and add it to uh, mm, mm. All right, give me a few more, guys. I'm just trying to. I'm just trying to add this. The year 3 students are also doing research methods. Guys, are you with me?
Year 3 Yeah, both year two and year three and year four would be doing.
Right.
Mm.
Environment. Oh, we finally open. Finally open now. So, sir, why the pupils for your class always small? Man, I understand. Don't forget the full room, man, sir.
For what?
Like when you're selecting the course, you select available seats.
Mm-hmm.
So normally, like stats and this course, I realize they only put 30, but the other classes they put 80, the full um availability of seats for the students to join. You mean to give the same amount, man? Then kind of a shortcut. It's the whole 1 year 80% decide to join.
Mm-hmm. There's a word that I can't spell. I don't know if you know what that word is. Politics.
Oh, sir, for research methodology, so how we normally select that course from any course from tourism, we have to do like two registration or two selections. So the one for main campus evening, and then we go over to tourism, and then the college has to make the adjustment there. So I'm not sure if you told that that's what we usually do. But that's the only way we can get all of the courses done.
Oh, because I'm having a difficulty now. It was seamless for me to copy the environmental science, chemistry and environment to the year 4 timetable because Paz brought it to my attention, it wasn't there. But now I'm trying to do the
Research methodology.
yeah, BS3. Okay, it went. But this is year 3. So I need to add year 3 and year 4. So I'm seeing it on the year
So
4
so
timetable.
so when we go on
Um,
Aaron, we have to select research methodology on a different campus.
Yeah, Camp Road evening.
Oh, Camp Road.
Mm-hmm. Remember that's what we have to do with small business.
Yeah, small business management. Yeah. Mhm.
Yeah. So them not charge us, and they wanted to charge us for the two things.
all right, so it's copied for that. Hold on, it's copied for the BSc. It's copied for the Thursday because it's supposed to have research methodology tonight, right? 8 to 9.
No, no. So it's Thursday and Friday, but the Thursday class, really and truly, it's Friday. The Thursday class is consultation.
It's self-paced. Okay, I see. It's a
Yeah,
self-paced. All right.
yeah.
You
So that
just
one.
sent me a while ago. All right. So let me just see if I can now attach the. All right. So it is there. It is there for the base. It is there for the Thursday for year 3. It is there for the Thursday for year 4. All right. Let me try it now for the Friday's class. Friday, what time is this again? 7 to 9. Let me try for the Friday's class now. All right. All right. So I have copied the. All right. All right. Just do me one quick favor again. Hold on. This is BSc year 4. Refresh timetable. All right. Check now, guys, to see if you. I'll just refresh the timetable. Just check for me now to see if you see the reflected times. So for year 4, I just added the chemistry and the environment, and I also added the research methodology. Just double check to see if you're seeing them, please.
No. Not
You're not
there.
seeing?
No. I'm gonna close it out completely.
Mm-hmm.
Yeah. Just like my calculator. So we say for that at the problem. Find student timetable. Alright. BSc evening. Year 4. Another. It's not changed. That's all.
Yeah, not seeing it still.
I'm sorry. Maybe there's another round of something else because last update, January 2021, 2025, 7:31 p.m. by Mr. Shand. All right, so it is
Repeat the date you said?
no, it's January 2021.
Oh, it's not registered as yet. Oh, only still saying January 19 at 6:06
Okay, because
p.m.
yeah, so I guess let me refresh it tonight. But yes, I've made the changes to the timetable. Thanks again, Paz, for bringing that to my attention. Because really, there should be no clashes because I mean those classes were already, and I'm not seeing any clash on the timetable.
No, man, there's
Uh,
no class.
right. So it's there now. Thanks for bringing it to my attention, please. Is there any other issue? I know I sent Sir the email, I mean a WhatsApp. He has not yet responded. So regarding the the work experience class, so as soon as he responds, I will get words to you guys. All right,
Okay,
so
because he knows exactly what to take to them because he was the one that dealt with them the last time. So it's best he goes there. To be honest, because they kind of ticklish with certain things, especially because you'll be actually in a harmful environment. So they want to ensure that certain things is in place. So he actually knows exactly what they need. So he's the best person to deal with it.
All right, no problem. All right, so going back to what it is that we did some time ago. We had a look at the states of matter. looked at solids, we looked at liquids, we looked at gases, and we also looked at the reactions of some of those, and we came to the conclusion that the truth is, when you look at the particles in a gas, they are widely spaced. Sorry, I was just trying to share. All right, I'm supposed to be there now. Supposed to be seeing it now. The particles in a gas are widely spaced. Those of a liquid are not as widely spaced as that of the gas, but you have gaps there. And for the solid, we recognize that, there's very little space that, takes place there. Because it's compact. What it, however, will undergo is vibrational energy. It will not undergo rotational energy because the particles won't rotate. There is no space for it to rotate. Think of you in a taxi trying to navigate your pocket, and you recognize that the car is so tight that it can't go in a pocket to pay the taxi man, right? That's exactly what the particles of a solid experience. So, so what it is that we're going to be looking at today, I really want us to have an idea of the movement of particles and how they move in, sometimes you don't see these particles moving, but they move. One of the things that is very dangerous, and times like now, you should be hearing, God forbid, of cases of people, and maybe Mikey can even tell us more of it. People, with snowstorms, people actually die in their cars because when they can't move or their vehicle becomes disabled, they turn on the air and the heater for them to stay warm. So this is what is happening now. They are in the car, they are staying warm, and they say, okay, fine, at least I'm not so bad. Let us see how long I can hold out on that. But what they don't recognize is that, the snow is coming down several inches, and it's building, and it's building, and it is now covering the exhaust on the motor car. So the gas that will normally escape, the carbon monoxide that will normally escape, is actually coming in on them. And because it's an odorless gas, they're inside there and they said, oh, fine. Oh. And they start feeling sleepy. And they start feeling sleepy. And they drop asleep, not recognizing that they're actually dying slowly from carbon monoxide intoxication. It's painless. You just think that you want to sleep, but what is happening is that the carbon monoxide, which is CO, and you'll hear more about it sometime later. CO. Carbon is C, oxygen is O. What is happening there is it is getting into your bloodstream because you're inhaling it. And what it does, it attaches itself to the oxygen molecules that is going to on the oxygenated side of your system, and it is rubbing the oxygen from your bloodstream. So it is that it can't get to the lungs, and then you die. You don't know. There was a situation reported of, I think, a family in a hotel that they were inside a room, the whole family was inside a room, and who not watching television, lounging, reading a book, those who are on the bed playing game support and so on. And the heater was on. Nobody recognized that because it's odorless. You can't smell it. It's not like when you put on your LPG, your liquid petroleum gas, and you literally smell the gas and say, oh, somebody turn on the stove and the gas is on. You can't smell carbon monoxide. And, the hotel recognized that they have not seen the family for a couple of days. And when they used the master key and went inside there, they were very dead. every member of the family. And I want you to go and research it. Go research it, look for the story, read the story. This is how we're going to get more information. So carbon monoxide is very deadly, and one has to be very careful, right? So I am going to show you, I'm going to show you how the fusion in gases. Matter of fact, I should just show you the video first. Let me show you the video first. Stop share. And then you can see what is happening here. New share. Oh, sorry. Let me pick it up first. Forgive me, had I been in the lab, I'd have prepared this for you myself. Well, what to tell, look at this. Who would have thunk that I would have been at Excelsior at this time of night? But it is what it is. I found the video, but give me half a second, please. Let me just. Are you hearing the video?
No. Okay.
Are you seeing the video though?
Yes, we're seeing the video.
Yes, sir. Seen the video.
Let me just pause it and share my volume. But it is audio.
Sir, why are they doing that? To show you how serious that particular gas is. The regulation here is that you have to have two sensors. You have to have one battery operated and the other one connected directly to the power. So if there's a power outage, you still can have some monitoring in the event you have a leak. And if one fail, you always have a backup. That's how serious it is because that gas will fill a building so fast, and the concentration will get high. And as you say, person just sleep out.
Yes, Mackie, you are correct. It is dangerous. Has anybody tried finding that story? My video is. All right, let me stop sharing and try sharing again.
It's a recent. It's a recent.
No, it's not. It's not.
Um,
It's not recent because I've referenced that a few times.
Okay. Because you have the most recent one is in Massachusetts in
I've
December.
seen a couple of them, a couple stories about the carbon monoxide. Some in
Poisoning.
2014, 2015,
Yeah,
2023.
yeah, man. It's
It was
serious,
in a
man.
hotel, right?
Hotel, yeah. You find it?
Oh, I think I'll find it.
But you know, they have the alarms though in the hotels where we
Yes.
can signal.
Right.
Yeah.
So that's one of the things now, and not just in hotels. So what they're doing now is like apartment complexes that are being built here in Jamaica now. Every apartment complex that is being built now, they have smoke detector and carbon monoxide detector. Right? Good type apartments that is. So it's something that you can purchase, you know. I don't know if Michael has one that he can just maybe show you, but it is circular. It looks like a bulla, the size of a bulla or Jamaica, and
Alright, let
it
me
has a
let me see.
you have one mic in nearby?
Yeah, can you see?
Yes, yes. And then now that button there, if he presses that button, the alarm goes off. So it actually tells you, it indicates, so if there is any carbon monoxide or carbon. Go ahead, Mikey.
I'm trying to remember this button again. Anyone?
You need batteries, man. Right. So the moment you hear that goes off, it's indication that something is wrong. Don't ignore it because it means that the level is high enough that it can detect it. So you have both smoke and carbon monoxide, and especially if you live in a basement where it is that you have, um, you know, these lots of pipes running. It's very important that you have one. But most companies know, most housing developments know that are being built with these detectors. And even if you don't have it, it is something that you can really go on Amazon and just purchase, right? And put it up there. It's very important. It saves lives. Um, you know, one of the things in Jamaica that we have to be very careful of, you know, everybody's buying a generator and they don't really know how to operate the generator. Them have the generator locked up in their house because them don't want rain catch a generator. And you know, the carbon monoxide is actually seeping under the door. It is actually seeping through the window. You know, it's coming back into the house and it is causing problems. So whenever we have hurricanes, you'll hear the Ministry of Health and Wellness and other agencies, maybe ODPEM, may come in to warn people who are using these devices, just to make sure that it is very ventilated. It has to be ventilated so it is that the carbon monoxide can escape because it is a silent killer. So it is advisable that, you know, the generator is placed outside if you want to create a shed for it. So it protects it from the rain. If you want it to be hoist so that if there's flooding, it doesn't get there because of course, you know, water and electricity really don't play. And then now you can run your cord, your extension, you know, through a tube. So at least it protects it there. And then you know that you're closing the place. It's very ventilated. The windows are closed, so you know that you don't have it. You know, the gas coming back on you because you may just go to sleep for life. It's very serious, guys. All right. I don't know what is happening to my audio. It's just, I'm trying to share my audio, but it's just really not working. All right. So what I'll do is I'll still show the video and then
keep your mic open and see if possible you can hear through your mic.
all right, so I'll still show the video and then see what happens. I can explain to you. Just look carefully to see what is happening here, please. Some of the instructions for demonstration. All right, so you're not hearing it. You can always look at the video, but what it is that he's doing there is just pretty much using a cork, and he's just pierced a hole in the cork here, and insert a cotton swab. You know, you have that cotton swab, you cut it in half, and insert that cotton swab with some of the ammonia, the hydrogen chloride solution, and then now he's going to place it in a tube. So this is where he has placed it, and he's going to use this rubber stopper to place in a tube. I have something to show you afterwards, but I'll just stop and explain as I go along. All right, so what it is that he's doing right there, this is a tube, a glass tube, and that glass tube is supported by a clamp and stand. So it is clamped to a clamp and stand, and then now he has just soaked one end in the hydrochloric acid, and he's going to soak the other end in the ammonia, and then he's going to stop. Use rubber stopper to seal this end with one and seal the other end with the other. Can you see something white being formed closer to one end of the tube than the other end?
Yes, sir.
Good. So it is, the gas is actually traveling. You are not seeing the gas necessarily that is being traveled at either end of the glass tube. However, when both gases meet, a white cloud is formed of ammonium chloride. So what is happening there is there's a chemical reaction that is taking place in this glass tube. Ammonia plus a hydrogen chloride is going to form the ammonium chloride, and it's going to give you that white ring. It's going to form that white ring. Let me annotate. It's going to form that white ring right here. And this white ring can get very a little bit more cloudy. If the reaction is going slow, I could remove the stopper and put more of each of the solutions to it. All right, I'm going to continue playing it. All right. So you weren't hearing that. I apologize. I'll sort out that my audio sometime soon before our next class. But I want to reshare something. Go back. So what I want to share now is a very experiment that we just did, right? And we're looking at the fusion in gases, the movement of gas particles, and it does so from a region of high concentration to that of a low concentration until you have that even distribution of particles in that environment. Remember, we spoke last class about someone entering a room having cologne, someone farting, someone, and we also have the fusion index with Craven Carrel went and took, try that thing with the syrup in water, and then, without mixing, after a while, the syrup, the concentrated syrup, will move from that high concentration to that of a low concentration. All right, and it also happens with your honey. Now, if you take, for example, the concentrated ammonia and the concentrated hydrochloric acid, and both placed at opposite ends of the glass tube. Here, I'm going to have ammonia. So this is my formula for ammonia, NH3, and this AQ means that it is aqueous, means that water is added to it. All right, so this is concentrated ammonia. And yes, you can have a concentrated solution that water is added to it. All right, and then at the opposite end, I have my hydrochloric acid, which is HCl, aqueous, and both are soaked on cotton wool. Both are soaked on cotton wool. And then what is going to happen now is that when both bung is set into this glass tube, and both bung set into the glass tube, what you're going to find happening is that the gases are going to diffuse from the ammonia and from the hydrochloric acid. They are going to diffuse, but there is something that caused the ammonium chloride, NH4Cl, to form closer to this side than it did this side. Can anybody have a hazard a guess why one set of particles travel faster than the other?
Is it because of the weight?
Very
Because light,
good.
I think, would travel far. That's my guess.
Even though this does not really work in all cases, I was about to say maybe a skinny person and a fat person having a race, but sometimes you may have some fat people who can run. So, but it's just the one is more dense than the other, right? And this is where now I'm going to be introducing to you the periodic table, because we need to know our elements on the periodic table. So what is really happening is that one gas particle is less dense than the other, thereby allowing it to move faster in the tube. Now, it says, can you indicate which particles is more dense? Tell me, which is more dense and which is less dense? Look at the formation of the ammonium chloride. Which is a more dense one and which is a less dense? Is this more dense or is this more dense? Which is more dense, the ammonia or the hydrochloric acid?
One on the right is more dense.
The one on
I
the
would
right
say
is more dense.
I would say the
Yeah.
NH3 is ammonia. Because, my reasoning is because it is forcing back the chlorine, the hydrochlorine acid. It's forcing back the vapor that is coming out from it.
So you're saying, so which one is saying it's more dense? Are you saying the ammonia is more dense or the hydrochloric acid is more dense?
The ammonia.
You're saying the ammonia is more dense? Okay.
Yeah.
All right, pass. I hear you saying that
Yeah,
the hydrochloric acid is more dense?
yeah, because it's staying to one side.
Okay, all right. Asia, what say you?
So I would say the ammonia.
You said the ammonia. Okay, Karen, come in and leave the syrup alone.
Sir, there's chicken this time. But
Please
now,
don't call.
sir, I say the same thing.
What you say? You say
What?
ammonia?
The ammonia?
Yes, sir.
All right, so it's just Paz alone that is saying the hydrochloric acid. All right, no problem. All right, let's go. So concentrated hydrochloric acid is denser because it has a greater mass. So the hydrochloric acid is going to be a denser gas in and of itself than the ammonia. And I'm going to tell you why. The mass of the nitrogen N is 14. The mass of hydrogen is 1. So you have how many hydrogens you have right here?
3,
3. And how many nitrogens you have?
1.
1 nitrogen.
1.
So 40, if the mass of nitrogen is 14, and you add 3, the mass of hydrogen, you're going to have the total mass here to be 17 grams per mole. You see what I'm saying? Chlorine has a mass of 35.5. Plus this one is going to be 36.5. So you're going to have 36.5 grams per mole. So technically, the hydrogen chloride is going to be much heavier than that of the ammonia. So actually, one is more than 2 times as much. So you may have, this one is going to be a little sluggish because it's going to take its own little time. And so this one is moving this way, but it's moving very slow. This one, on the other hand, is moving and moving very fast. So it is moving so fast that it don't give this enough time to get close down here. So maybe if I had put this one in here long before this one, maybe the ring would form somewhere here. But remember, well, you weren't hearing it. I invite you to go and watch the video. Both plugs are set into the tube at the same time. Both plugs are set into the tube at the same time, giving it an equal opportunity to move. So it is that we can test the rate of transfer. So it's not that we put one in before the other. Both are plugged at the same time. So because the hydrogen chloride, the mass of it is heavier than that of the ammonia, the gas particles here are going to move slow. The gas particles from this side will move much faster. And in so doing, you're going to have your compound. This is a new compound that is formed now. And the combination of this is as a result of this and this one. So this and this coming together to form a new compound. And this new compound is called ammonium chloride. Both of these liquids are very toxic. Liquid ammonia is very toxic. If you inhale it, you can actually pass out. And the hydrogen chloride gas is very toxic. It's one of those mineral acids. It burns and burns pretty fast and pretty hard, painful. All right. So in the video, you'd have seen where the demonstrator was actually, wearing gloves, because you can actually, if a drop of the acid touches your skin, it is actually reacting with the oil on your skin, and it's going to burn and burn and burn and burn and burn. Matter of fact, I'm giving you all these stories because I want to go and read so it is that you can see the chemistry in it. There was a situation some time ago, can't remember, I need to keep these dates in my head, can't remember which year it was. Common law dispute. And the woman was so upset with the gentleman for what maybe he did to her. But the gentleman was on the bed with their son. And the woman entered the room and poured some liquid on the gentleman. And it literally burned his stomach out. And it went through the mattress and left a gaping hole in the mattress. What it is that it threw on him was concentrated acid. Very dangerous. Don't play with it. Very, very dangerous. As a matter of fact, sometime, I think December of last year, there was some alert on TikTok that to avoid half a tree because some guy threw acid on a lady somewhere in half a tree. It's very dangerous, very, very dangerous. All right. So when we are handling it in the lab, we have to use protective clothing. Matter of fact, all of this, normally when I'm doing this experiment, my solutions are prepared in a fume cupboard so that the dangerous fumes can actually be escaped and not be in the lab itself. Because anyone suffering from respiratory problems inhale this can actually get into shock. All right. So, any questions relating to this?
No, sir.
Okay, I thought you went to sleep.
No, sir. I shared the video in the chat.
Okay, thank you. So Mikey has shared the video. Thanks, Mikey. So you guys can download the video, um, and just watch it, and then you can look at other videos, just to see exactly what is happening. All right. Okay.
Sir, quick question.
Go ahead.
This is the same ammonium that they sell as melon sauce.
Yeah, man. It should be the same. Ammonia is ammonia. So it would be.
Just a diluted version.
Yeah.
And it's still strong. Yeah.
And it is still strong, yes. So you have to be very careful with it. It is used if you're in architecture, when you're in blueprints, the blueprint is actually done passing through a solution of ammonia. And if you're in office when that is being done and you have respiratory issues, you have to move because a bottle of ammonia is there. And this is what causes the blueprint to come. So when these contractors, that's what they read to say, okay, we're going to put a beam right here, a column right here, 2 bedrooms been on this side, 4 bedrooms. So this is what they read, what we call the blueprint. And it is literally a blue piece of paper. It's a white paper that went in, but when it comes out of the machine with the drawings, it then becomes blue. So they call it the blueprint. But yes, even though it is diluted, it is very still toxic. All right. And then last week, we also had a conversation about diffusion in liquid. And Carol did an experiment and told us. Did anybody try it on their own?
Not as
With
yet,
the
sir.
honey was I did have to do a little bit of stirring.
Okay.
But
All right.
yeah, what happened? I used a little bit warmer water because it's very cold, and it's once I poured the honey started to the water onto the honey started to dissolve. Oh, but it was sweet. But when you do the reverse, literally wasn't sweet. Could hardly taste the honey, and you have to mix it out for you to actually get the taste.
Right. And you'll be correct. All right. What I want you to do for me, I don't know which of you using a device that you could find this for me and share it. I'm going to tell you something here, and I want you to find the video and find a video for me. And or maybe I could look for the video. Hold on. This is nitrate, potassium iodide. You can read that paragraph for me, please. I'm just going to find something. Nitrate and potassium iodide reaction. Um, all right, so I'm finding, okay, good. This is, all right. friend me a while ago. I'm trying to find. Copy URL. Pause. All right, I've just pasted the URL for this video. I'm gonna ask someone to just share it, and hopefully your volume can be shared, and we can both watch it together and we can talk about it. Please and thank.
Sir, give me a second. Oh, sorry, I have to stop share screen so I can. You guys hearing the video?
Yeah, man, yeah, man.
Okay. Yes, sir. The video finished.
All right. Very good. And thanks, Baz. Anybody figure out what is happening right there?
It's kind of confused.
All right, let me see if I can clear it up a little.
I feel like the weight fell on the scale. That was obvious in the last part. So the weight increased, and then once the mixture started, then the weight reduced. So
Yeah, but what happened though is that at one end he placed some crystals of lead nitrate,
yeah,
and then at the other end he placed some crystals of potassium
Potassium
iodide.
mm.
And then as
and
those
form
two
of
solid
solution.
crystals, right, as they start to dissolve and diffuse in the liquid, you can see the bright yellow precipitate of lead iodide that was formed. So technically, this is what was happening. You have your potassium iodide at one end, whichever end you want to put it. And then you had your lead nitrate at the other end. And then now both are going to diffuse, And then when it diffused now, where you see this line that is being formed, it's going to be a bright yellow precipitate of your potassium iodide. My question to you is, which of the compounds is more dense?
The lead nitrate.
Okay.
Sure,
What
you
about the
can go
other?
back up to the formula.
Huh?
Can you go back up and listen to the formula of the two?
No, I don't have the formula, I just have the name of the compound. Potassium iodide and lead nitrate. That is potassium
I would say
iodide.
potassium iodide.
You said the potassium iodide?
Yeah.
Okay. Rest of you?
Does the same principle that applies to the gas applies to this form diffusion in water,
Mm-hmm.
where the heavier one, oh,
It's not,
then
and that's why I asked the question the way I asked it. That's why I wanted to answer me. What do you think is the mass of the, and I mean, I asked the question because I know we don't reach it yet, but I mean, I know Google is there. What do you think is the mass of potassium iodide versus the mass of, all right. Don't answer that yet. That is going to be your homework. We're going to do that one for homework.
Sure, as in the actual mass, like a number.
Yeah, the mass in grams of the compound. Yeah, just like how we
Okay.
did the mass in grams for the stuff. But
yeah. So, well, lead nitrate, lead normally with a heavier cause lead is heavy. Let's say heavy as lead. So, and the weight is 331.2 compared to potassium iodide, which is 166.8. Yeah, 166 gram per mole. So lead will actually be the heavier one. But
And
why did it lose the weight, lose the mass? Why did the solution lose mass?
So one of the things that I want to tell you though is all nitrates are soluble. Every compound that has nitrate in it is soluble. So for example, when you talk about your NPK, your nitrogen, your phosphorus, and your potassium for your fertilizers, potassium nitrate is one of those fertilizers that we're going to be using. Why? Because of its solubility. So the nitrates are soluble, right? So lead nitrate is going to be soluble. Yes, we know it's heavy, but it's going to be soluble. So that's why it is that you are able to see that dissolving. I say that to you because once you hear about lead, you're going to say, Jesus, no man, lead heavy, and it's not going to move. Once you have the lead nitrate, it's going to be soluble. So all the nitrates, all the compounds with nitrates in it are soluble. And one of the ways you can find that again is in your fertilizers. You're going to be looking for those that are soluble, so that when you put it in it and you water it, it dissolves. It don't make sense when you drop your crystals in there, or you try to mix it out to water your plants to give it nutrients. It takes a year and a half to dissolve. That don't make sense. It's not going to help the plants. So these are going to be very soluble, and then you are able to achieve what it is that you set out to achieve. All right. Are you following what is happening so far, though?
All right, so sir, my question now, based on what you just said, is it that because the lead nitrate will dissolve into the potassium iodine, is it that the potassium would actually be heavier than the lead nitrate?
And that's what I'm asking you, because I want to make a comparison based on the conversation we had with the ammonia and the hydrogen chloride. But I am going to
that's what
give
I
you
was thinking. I was thinking that it would have been a similar situation.
and that's why I asked the question, because I want to clarify something, but I don't want to just be the dispenser of all knowledge. You guys have to read something for yourself. So that's what I'm saying to you. You're going to check for me the mass of the compounds to find out which is heavier. You're going to check the mass of the potassium iodide, and you're going to see if it is more than the mass of the lead nitrate, and then you see something, and then we're going to have that conversation. Yeah, man. So I'm not going to tell you that just yet.
It's basically twice the weight. The mass of lead nitrate is basically twice the weight of the potassium nitrate. But one would
what is the mass of lead nitrate?
331.2 grams per mole.
And what is that of potassium iodide?
166 grams per mole.
So which one will move faster?
The potassium
iodide.
Okay, so is that depicting in this diagram that I have here?
Yeah, I would say so.
Yeah, it is depicting. So from my look at this, I can tell you that the potassium iodide diffuses faster than the lead nitrate. That's what this is saying. So even though the lead nitrate is soluble, the potassium iodide diffuses much faster than the lead nitrate. And this is why you have the potassium iodide being formed closer to the lead nitrate, because one is more dense than the other. So the lead nitrate is going to be more dense than that of the potassium iodide. Got it?
Oh, okay. So, all right.
Yes,
so,
sir. Yeah.
Is that the right? And it's diffusing towards the left, so the lead nitrate crystal.
Right.
And once the two combine, that's when you have the chemical reaction that basically turns everything. Okay.
Absolutely. So you're clear now?
Yes, sir.
All right, so let's just have a quick discussion, and then I'm going to show you one other experiment, and then we end right there. All right, so the lead nitrate and potassium iodide each dissolve and begin each dissolves and begins to diffuse through the water. So again, last week we spoke about it. Carol did it. We have the fusion in liquid. We have the fusion in gases. All right. When the lead ions, see it here, when the lead ions, Pb, meet, they react to form a yellow lead iodide, which precipitates out of solution. All right. So in the video, I showed you the video because me showing you this alone will not show you what color precipitate was going to be formed. So you have a bright yellow precipitate that is going to be formed of the potassium, of the lead iodide. All right, of the lead iodide. So, and the lead iodide is going to be precipitating out of solution. It's going to be precipitating out of solution. The precipitate does not form exactly between the two crystals. This is because the lead ions is heavier. See it right here, so no, Mikey? The lead ions is heavier and diffuses more slowly through the liquid than the iodide ions. The lead ions are heavier, so it takes a little while to diffuse. Take a little while to diffuse, take a little while to diffuse. It's just like you have someone who is geriatric, who is walking, going to take them time, going to take them time, going to take them time. But a young person now will say, yo, you're too slow, man. I can't do this quicker than you. These are heavier, so it's going to take a while in order for it to reach this one. So it's not going to be dead in the center. Why? Because the lead ions are heavier than those of the iodide ions. Make sense?
Yes, sir,
Yes,
definitely.
sir. Yes, sir.
Got to. All right. Now, we're going to talk about osmosis. Anybody know what osmosis is?
Uh,
Oh,
so
yes.
I guess for me it's a reaction that moves that allow particles to move from a region of low concentration to high.
Or is it high to low?
High to low. Because
Okay.
when they do the potato salt water and the potato it moves from one to the next. Yeah, from high to low.
But there's something else that is missing. Very important thing that is missing.
Through a
I think it goes
semi-permeable membrane.
yeah,
Through a
semi-permeable.
selective permeable membrane. Through a selective permeable membrane. So you have to have that selective permeable membrane in order for that to happen. Now, let me just explain something to you. Practically, osmosis in real life. You know, you go to market and you want to buy your callaloo and your pop throw and your lettuce and your kale, and you see it and you pop and your I said pop throw, and you see kind of just and your celery, your leafy veg, and you see it look dead like it have no life because of the heat. The water molecules them dry out outside. So sometimes you see the man them who sell color upon the street side have a bottle of water and them are sprinkling the color with it. It's a science, you know. It's a science of it. So when it is that he's sprinkling the water on the color load, is that what it is doing is that the water molecules are going to eventually get into the stem of the color load, and it's going to fill it up, and then the leaves going to stand up big and firm because it is fully hydrated. All right, it's fully hydrated. So And it also happens with potato, as Michael says. You know, you can have we can do an experiment with the potato with some salt water and fresh water, or we can soak the potato in salt water and see what happens, and then we'll put it in fresh water and see what happens, right? So it's really the movement of particles from a region of high concentration to that of a low concentration, but it does so through a selective permeable membrane, right? So it says, although osmosis is the diffusion of water, alternatively rather, osmosis is the fusion of water or any other solvent through that selective permeable membrane, all right? A simple rule to remember is that salt sucks. Salt sucks, right? Salt is a solute. When it is concentrated inside or outside the cell, it will draw water in its direction. Put it this way. Don't know if you eat pork, really not my concern. But if you had a big bowl of red pea soup or stew peas, and you burp 2 times, what else you want?
Some water.
Same way, so.
20
Right about now, I don't know if it's you or Carol, which one of the two are more craving now, you know.
Really.
Yeah. You know, this Carol can't talk because I know the chicken can pass
No,
her
No,
throat.
sir.
no,
No,
cool,
no,
cool.
no, 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 no. We're not doing that, sir. Pass back bigger than mine.
As they say, them a join it was.
Yes,
All right.
sir. What realize.
Yeah, man. But yeah, so salt sucks. So when you have that bowl of stew peas soup or beef soup, man, with something inside of it, and it got all nice and say, yes, you want more water, you want more salt sucks. So what it's saying, salt sucks. Salt is a solute. When it is concentrated inside or outside the cell, it draws water in its direction. So just remember that. You want the water because you want to dissolve whatever extra salt that is inside of you. All right, put it this way. If you and I are running or walking in the sun for quite a while, we get thirsty and we want more water, you know why? Because we perspire and the water molecules that are inside our system, in our cells, dry out. And then the salt from the foods that we eat is very concentrated inside our bodies. You see
Or
that?
if you eat a lot of snacks. The
And if you eat a
sodium.
lot of snack, it makes it worse.
Yeah.
If you're one of those people who snack a lot, it makes it, and especially salty food, it makes it worse. All right. And sometimes what happens too, you can actually literally feel the salt crystals precipitating on your skin. Anybody ever see that or feel that?
Yeah, man, all the time.
Sir,
Oh,
Yes.
only
that's
for
what them
jazz.
call sweat mark. That's them call sweat mark.
Yeah, man. Yeah. So I'm gonna project this thingy bob here, and we're gonna have a conversation about it. All right. So I want us to pay attention to what is happening here. We're going to be looking at it again. We're having a conversation. I'm going to point out some things, and I want you to also look and agree or disagree with me as we together, trash this thing out. So I have my tube. One is a hypotonic solution, and one is hypertonic. Hypo and hyper. When somebody is hypertensive, well, let me not think about it.
High blood pressure.
Right. And you ever hear somebody having low blood pressure? What is low blood pressure called?
Hypotension.
Okay, hypo, right?
Yeah, hypotension.
Good.
Yeah.
So hypo is when it's low or less. Hyper is when it's more or high. Follow?
Yes, sir.
Good. So look at my water level. What do you see happening here with my water level? Do you think the water level is the same on either
Yeah,
side?
it look level.
Yes, sir. It
Yeah.
look
You can
like it's the
say.
same.
Yeah, man. Yeah, man. It look level to me too. Yeah, man. Asia Gansley. It look level. It look level to me.
Oh, I'm here, sir.
Okay, good. Midway between here is my selectively permeable membrane. That's my selective permeable membrane. All right. It's a membrane that allows things to flow through. Right. It's my selective permeable membrane. I have less solute. Solute are the things that are being dissolved, and the solvent is actually doing dissolving. Follow me?
Yes, sir.
So
Yes,
in the
sir.
case in the case of sugar and water, which is a solute?
Would be the sugar,
Would be the sugar, and the
Sugar.
solvent is
the
The
water.
water.
yes. So the solute is what is being dissolved, and the solvent is what is doing the dissolving. All right. So you know that you have less solute, the substance that are being dissolved here, and you have more over here. So, all right. Are you following me?
Yes, sir.
Yes, sir.
Yes,
So
sir.
far.
I
So,
understand.
so, so, so now that you know what a solute is versus a solvent, remember the solute is what is being dissolved, and the solvent is what is doing this, the dissolving. All right. So I'm going to give you a compound now. Say, for example, salt. So I have more salt crystals on this side. Can you agree? Let me spotlight. Can you agree that I have more salt crystals on this side, right here? So
Yes, sir.
Yes, sir.
very good. And I have less salt crystals on this side, don't?
Yes, sir.
Yes, sir.
Good. What did I say about salt? What it does?
It attracts the water.
It sucks, right?
Yeah.
Yeah, it's stuck.
So what you expect to happen right here then is that this side, because it has more solute, more salt, it is going to pull more water to itself. True or false?
True.
Yeah, man.
Okay, crazy.
Because yeah, it's craven, it's Carel. So this exactly what
Use
happened.
somebody else for the craven, no man.
So what is happening here now? So it is pulling water from this side because remember salt sucks. So it is pulling water from this side so that it can evenly distribute itself here. So look at what is happening now. The water level on this side is going to be higher. Does that make sense?
Yes,
Yes,
sir.
sir.
So look at what
Sir,
is
and
happening
the
now.
first me ever see this and it makes sense.
Say it again, Mikey.
And the first me ever see this and it makes sense.
Yeah, man. Yeah, man. And then look at what is happening here now. It comes this way, and because it is pulling water from this side that is hypotonic, this one has more water. See there, higher water. This one has less water, so it's pulling water from this side. So the water level is going to go up here. This is going to go down. But look at the solutes inside here now. Does it look like it is evenly distributed here now? Throughout?
Yeah, yeah, it
Yes.
does.
Mhm.
Mm-hmm.
Yeah,
So,
I
because
don't.
so that's
it's no
exactly what
longer
it is.
compacted.
Right. So that's what it is. So that is diffusion, sorry, osmosis. That's what
Sorry,
osmosis
help me with
is.
the last part there, sir. With the if it look like it evenly distributed. Because to me it don't
So,
look so.
so all right. Do you see the selectively permeable membrane right here?
Yeah, yes, sir.
Do you how many out of this side with the solute and this side, the right hand side or the left hand side with the solute? Which side has more?
The right hand side.
Good. Let us look at this one here. Which one do you think has more?
The right hand side.
Don't say that because the right hand side have more water. So you can have more solute in there. Watch me pass. If I come somewhere right here, so somewhere off here, so would be the halfway mark right here. So talk truth.
Yes, sir.
Talk. You agree?
Yes, sir.
All right. Let us count. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. And about the same amount.
Yeah.
Yeah. But you have more water in here, so you expect to have more solute inside here. So for me, it is evenly distributed. The solute in the solution is evenly distributed because the water, the more salt from this side or solute from this side is pulling some water from here so that it can have an even distribution.
Yeah. Yeah.
You see that now?
Yes, sir.
All right. So the hypertonic solution is the one that contains less water and more of something else. This, less water and more of something else. More of the solute that is being dissolved. More of the solute that is being dissolved. Agree? Disagree? Or we stay?
Agreed.
Yes, sir. I agree. I agree.
All right. I did say that, but I think I just want to put in one more. I know, and why I want to do that because we use a little bit of the time just to add those 2 courses to the timetable. And I had planned to do one more quick experiment. You know, let me see if I can. All right. Maybe I won't do that. Let me just have this conversation with you. Let me hear those who can cook. Carol, don't put up your hand. Let me hear those who can cook.
Yeah, chef long time.
All right. Pause or you stay.
Sir, I can learn a little bit more, but I can't help myself.
Asia?
You can cook ramen and conflict.
Yes, I forgot to change that, you know.
No, pause.
Yeah,
What Asia says
like
she can. Pause. What Asia says she can cook.
So current flakes.
You notice Carol can't talk?
Hmm.
All right. So we need to do a little cooking class in chemistry class. But I want to ask you a question though. And I mean, it's a learning process. It's a learning curve. You know, our parents sometimes taught us lots of chemistry in the kitchen, and them don't even know say chemistry them a teach we. And we didn't even know say chemistry we're learning until we start learning chemistry formally. Because sometimes
When
the
it's off
cooking,
the pot.
when them salt the pot, when them put in the pot, Mikey,
And because of so Irish potato
or what?
and put sugar.
No man, Irish potato, you're on the right track. Irish potato,
Uh,
carrot,
and
chocho.
carrot, chocho and all of them things.
Yeah, man. Because what it does now, and when you ask the parent, so why you didn't put that in there? Oh, because it gonna add flavor and them not telling you that they don't know the chemistry behind it. So um when you add potato or Irish to a pot that is somewhat salty, what is happening is, remember, salt suck, so it is actually going to be moving from a region of high concentration to that of a low concentration through a selective permeable membrane. So because the pot is more salty than the water that is inside the Irish potato or the carrot, the Irish or the carrot is going to pull the salt towards it. So therefore, you will have less salt in the pot. So sometimes you see, man a cook pot and then I say, oh, wow, you have any Irish? And then just peel the Irish and just drop the whole of Irish into something. Them not going to eat that afterwards, because that is going to be a little salty. But them just drop it
I
in
was
there.
just about to ask that. Yeah, like
Yeah,
a waste
man.
of Irish.
Yeah, man. But guess what? But guess what? The truth of the matter is better them with an Irish or two than
Yeah,
the whole
same
pot of food
here.
can't eat.
Yeah.
Yeah, man. So it's a chemistry behind it that has caused the whole business of osmosis. It's the whole business of osmosis that has caused you know to be able to do this stuff. Yeah, I mean, you know, sometimes we put the carrot in there and guess what? And every time we're cooking or like curry chicken, and they would drop the Irish in there. People continuously taste them pot because it makes it blow. It tastes kind of fresh. It want a little bit more salt because the mere fact that you put your Irish or your carrot inside there, it pulls some of the salt from the pot. So which is why when people cooking them, continue tasting the pot and continue adding more seasoning or more salt in the pot to flavor or to taste, don't it?
Yes, sir.
Yeah, man. It is what it is. It is what it is. All right. I have 12 minutes. So let me just do quickly this other one. Now, let me ask you, have you ever, and I don't expect any of my students to be smoking, so I'm going to, and if you do, I'm going to ask that you stop and stop immediately. But if someone is burning and you shine a light, you know, somebody burning along the road and then you're driving and you're like, what is that? And you turn on your beam. What do you think you will see?
So someone is
What?
burning like on fire.
Yeah, man. Somebody burning that bush, you know, that burning
Oh,
rubbish.
Oh.
I thought you mean somebody like was unfair.
And that would think me too, somebody
Yeah.
on fire.
No,
Sorry, I didn't know.
that would be callous. That should not be a chemistry class. That would be a class for GP or for something they're gonna lock you up. Mm-hmm.
I'm serious, it's smoke I come off
Foggy,
fire.
it looks foggy.
Talk to me. Somebody was saying something.
Yeah, I'm saying you like sick fog.
You mean say
Oh,
something
it's
like
smoke
fog?
coming off.
Yeah.
Yeah.
Yeah, it's smoke.
Mm-hmm. Right. Carol gone, you know. Right. So you will see, and then know what you expect to happen when you see that.
Like reducing visibility and might slow down.
Um, is a little uh sure. All right. Look at that. There's no sound to it. It's just something they
Oh, I'm
call
not seeing it, sir.
hypnotize. Oh, you're not seeing it?
No. Mm-mm.
You should see it now.
Not seeing it now. Yeah.
So you see we're shining the light through the smoke there, and you can see the sort of rapid, haphazard movement of the particles, and it pretty much like it's
Oh, yeah.
dancing.
Yes, yes, sir.
Mhm.
Similar like the gas in the tube. Kind
Similar
of
like the
form
gas in
like
the
that.
tube. Right,
Yeah,
right,
yeah.
right. Now, and put it this way, if you come from country and you see this, you're gonna tell people say rolling calf the boat.
Yes, it's
And and you did it over Mass Draw Yard, and Mass Draw they did last year, and Mass Draw not sleep because Mass Draw come every night, but you don't recognize it. It's because them keep burning, and the light from the street light now start to cause the smoke to dance. And people said, no, man, a maestro come up, man, because they never used to treat maestro right, you know, so maestro won't come back for the film house. You see what I'm saying? I mean, people are just superstitious and they find lots of things to explain lots of things that really don't go so. But there's a chemistry behind it.
Or if you go throw some ice on the roof in the night. Nobody
Oh,
now live
Jesus.
in a lot of
Oh, Jesus. Trouble. Trouble. Matter of fact, old time people used to say, like when Christmas time come, them buy whitewash and whitewash the sidewalk and the base of the tree trunk. Anybody see that happen?
Yeah, man, they used to
No,
do that.
sir. Not me.
Right. Why did you whitewash the base of the tree trunk?
I thought it was for the look.
Okay, all
No.
right.
Well, we normally do so that things like insect na go for eat out the eat off the leaves and all that stuff.
And that's a
Oh, is that
reason.
the reason?
And that's
Okay,
a,
yeah, yeah, yeah.
that's a real reason. So
Trying to
ants
kill the
and
tree.
lizards and slugs and snails and them something there
Mhm.
will not go up and eat the fruit for argument's sake on the tree, right? So that's why people whitewash the stuff. So it also adds a bit of aesthetics to it, Asia, don't get me wrong. But the primary focus on it is not really to get the aesthetics, is to prevent it and to preserve your stuff. But guess what? The compound in and of itself that is whitewash. When people sit on one of them tree that with them whitewashing out, them start for choke. And you know the old time people say, rolling care off the boat. But the truth of the matter is, it is emitting carbon dioxide. So it's you and it competed for the oxygen. So you want to feel like you're out of breath. So people will say to you, they say, whenever you sit on that tree at nighttime, it'll choke you. That's not what is happening. It is a chemistry behind it. But the old time people, them never know the chemistry behind it. So them formulate all manner of story. And then because it happened to you, you believe it. You see how life is funny? So,
I don't feel Max boy, man.
say it again.
I don't feel that choking, man.
And that's exactly what it is that they are going to be saying. They are true people, far from the truth. All right. What I want you to do for me in preparations for class on Thursday. Let me just see where I'm at. I want you to be reading, students. I want you to read. I want you to be reading on areas that we've covered so far. The things that I speak about in class, I don't want you to just take it lightly. I want you to go and look at it. There are some other areas that I need to talk about in terms of solubility, the periodic table. What I want you to also start doing is to print off a copy of the periodic table. And I want you to be able to study the first 20 elements of the periodic table. And you need to know them. You need to know its mass number, you need to know the atomic number, the number of protons, the number of neutrons, the number of electrons. It is a requirement. You must know it. Let me just share what it looks like, and that's going to be the end of my class. But that's what the periodic table looks like. All right. Now, the first 20 elements will take you up to calcium, from hydrogen to calcium. So hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. So you see that they're color-coded. The ones here in the middle are called transition. The ones here are reactive metals. The group 2s are also metals. These here, the group 8, are noble gases. So when you go to New York and you see, one of the things that I like about New York is that people don't need They don't need no street light in New York because all of these buildings are well lit. So you're walking up and down in New York at night, and really and truly, you don't know it's night because it is.
Yes,
Yeah,
that is true. That is so true.
yeah, it is
Even
so
birds.
well lit. You don't know. Matter of fact, when you go into a store and you see the sign says open, and you see some shocking colors, and you say, wow, those colors are nice. Is this little one here neon? Right? And then now, of course, this is the oxygen that you and I have to live on and breathe in, and this H over here. So you notice this H over here, so have the same color like them one over here. So yeah, man, we're going to talk about these, and we're going to look at some trends here. These are my very toxic looking stuff. So let us look at something here. My lead PB, my lead is right here, right? The mass number is down here, the atomic number is up here, right? Iodide that we looked at earlier is right here. Potassium is over here, right? The nitrate is NO3. See the N here, see the O here, right? So all of these, right? So all of these here, all the compounds that we want to talk about are found in the periodic table. Every single one of them are found in the periodic table. So you need to know there are some reactions that you will have to do. There are compounds that you have to draw. We have to know the electronic configuration, but I soon give you those, right? So what I want you to do for me, is to go and study. You can print off something like this. You need to know the first 20 elements of the periodic table. The first 20 elements of the periodic table must be known. I need to know the atomic number. You need to know the mass number. You need to know the symbol. And we also need to know the electronic configuration, the number of protons, the number of neutrons. It's really not difficult. I'm going to give you an exercise. I may call it a graded piece, but I'll explain all of that. I just want you to be familiar with the periodic table. Print off one. I'd love if you print off a color one. When I was going to school, we never had them something here. We only had black and white. So you have to imagine what they look like. All right. And then we're going to have conversations about oh Lord, I shouldn't have done that. We're going to have conversations about how some of these minerals literally precipitate out in nature. When you go into the ocean, for argument's sake, you have this one here, cobalt, precipitate out. Ag, silver, precipitate out, right? Au, gold, precipitate out, right? Yes, unfortunately, have some mercury there that we don't want to have because I mean it's very poisonous. But some of these things are very important. This one is important for what you and I have to use to build houses, or iron, right? So you need to know who they are. You have to respect them. They form life. They form life. All right. All right, guys. Thanks for coming out. Any questions?
We're gonna get multiple choice for section A for the final exam.
No,
No? Okay.
no. Let me just tell you. Let me just hold on. Let me see if I can give you an update as to, yes, you do get multiple choice. Actually, you get multiple choice.
It's
You get
very,
multiple
it's
choice,
very
but
like that.
you
Mm.
get multiple choice, but you also get a compulsory question. You get multiple choice, but you also get a compulsory question. You also get a compulsory question. So you'll get I think 20 multiple choice questions for the exam, or 30. I will tell you. I think you get 30 multiple choice questions. 30 multiple choice questions, and then you are going to get two. You're going to get you're going to answer 2 questions. 30 and 30, 60, that's 90. No, that don't make no sense there, no. Hold on there. Let me just confirm something.
Normally 20 them give you know.
Hmm?
Normally 20 multipliers them give you.
Yeah, I think there's something. Let me, looking for the outline. I gave you a copy of the outline, don't?
Yes, yes, yes,
Yes,
sir.
you do.
All right, let me just find the course outline because I'm actually spelling and guessing, and I don't want to do that. So let me see if I can share this. It's important, an important question. Let's see, exam. Right, so it's a 50-50 course, and it doesn't say, it's a 50-50 course. So 50% for coursework and 50% for exam. So if you do very well on the coursework and get 45 out of 50, you are very close in passing the exam. So just don't play with the coursework and just do a stellar work in the stuff. I'm trying to remember what it is I told you now. I'm not even get a compulsory question though on the exam. They give you a compulsory question to answer. So you must do, they will say like answer question 1 and any other question or something like that. Let me just see if I can find, when are we in now? 2025? Hold on, let's see. All right, I will let you know by Wednesday. I can't find it now. I'll let you know by Wednesday.
All right, sir,
But
no problem.
man, big up yourself though, yeah?
All right, sir.
Okay.
Thank you.
All the best. Cool.
All right.